They are. And so in SLS, for instance, I can't print anything that holds, and there's also other things of like, if I want it to hold water, I can't, or like hold pressure, like actually be like a pressurized container. In SLS, I can't do anything thinner than 0.3 millimeters. If I want to do that in SLA, I think I can probably go down to 0.1. But it depends on the specific machine and even the orientation of parts. So like if, for instance, on this part, I can get it in this material. This part was printed at 50 micron layers. Also, the layer thicknesses is important too. And so this part printed at, I think, is 50 micron layers. I can print a 300 micron wall structure around the whole thing. This eggshell is 300 microns thick. When we bumped that up to 100 micron layer thicknesses, we noticed that the 300 micron wall wasn't quite doing it anymore. So I had to increase it from from 300 microns to 400 microns, and then that solved all of the problems again. And so, but there was a lot of like subtle little different things that, and even the angle of the surface to the layer, like if you have a really shallow surface, you're like the amount of area that it's covering per the next step. I'm describing that strangely. But very shallow surfaces are hard to print because the layer lines basically get really striated and really far. Where like a vertical surface, you may not even see the layers at all because they're all perfectly stacked on top of one of themselves. And so like this is a really organic part on it, and it just happens to be oriented in such a way where the actual straight portions of it print really well. But there was definitely, in the 50 iterations I did of this part to try and figure out what the best orientation was, some of them really looked like perfect, and then I would like inject them full of silicone, and it would leak in some part I never saw before. Like I just tiny little hole somewhere where like one of the layers was just slightly too small or too big for that one particular application. But there are definitely rules of thumb. There's a website that's run by Patrick Dunn called Unconventional Manufacturing, and I wish I could bring it up right now. Let's try my internet again. This worked yesterday. I'm running it off my phone. I have no idea why it doesn't work. Let's see if I can connect. But Unconventional Manufacturing's got a lot of rules of thumb or even design techniques for specific applications. Like for instance, with this SLS duct here, this SLS duct was not, like the geometry was not only refined to print in SLS, but even the cleaning process has been refined. And so with this case, like cleaning really long tubes that are full of powder is normally very difficult, or like considerably more difficult than say, if it was just the hexagonal structure and I can just shoot it with a bead blaster and all the powder would come out. And so what I've done in advance is model basically a chain through the inside of that part. So when the Service Bureau prints this part, they basically just pull on that ring, and it'll put a nice channel all the way through the part, so when you blow air through it, it's not getting trapped by like a blind boss. And so that alone, that little chain that takes 30 seconds, not even 30 seconds, 2 seconds to pull out at the beginning, probably saves you 10 minutes in the cleaning process, because you're not sitting there trying to like, maybe with your finger or a long stick, trying to poke out all the powder. And so like little details like that can save you an enormous amount of time cleaning. Like if that chain was to save you even 30 seconds, but you were making 700 of these, that's a lot of time over a period of time. Like I think we printed 700 little jewelry rings, and there was one detail on this part that was hard to clean. Times 700 times meant I cleaned parts for 8 hours that day. It was nothing, I did nothing but that all day long, was just sit here and clean that part, where like if you just didn't design that little detail, and you wouldn't know it until you tried to clean it. So having to finish your parts also is somewhat useful, because then you can be like, I don't actually, like it's really annoying to clean this one undercut. I don't need it. Like it's not important to my overall design. If I just don't put that undercut there, like hours or years get saved off of the overall manufacturing time. And so let's see if my internet works again. Connected. Doesn't like it. Interesting. But Unconventional Manufacturing is a fantastic website that goes through a lot of different, basically, design techniques for SLS, and then there's SLA on there, I think, as well, and just different little like techniques for solving issues. Like for instance, in a lot of things we get they're called blind bosses, and so someone will basically want to screw something into a something. Let me actually make a different shape here. So someone will want to screw, anything. Maybe this is just a fastener on something. We'll get a part that looks like this for printing in SLS. Let me merge it all together. Boolean union. And so like this is a very simple part, but it's hard to clean. For instance, if there's powder in this hole here, and I'm trying to like basically with an air compressor blow that powder out of that hole, or even with a like a toothbrush or whatever, like somehow get the support material out of that hole, it's very difficult. There's nowhere for the very bottom % of that powder to go. Once it's down there, like I basically have to break it up with basically a stick. I've got a lot of metal wires that I use to poke out holes like this. If the designer was to literally go and put a cylinder at the bottom, or like punch a hole in the bottom of this structure, which maybe doesn't even affect the design at all. Like maybe it's just a tiny little detail right here that you may never see. Boolean difference. Now there's a place for the powder to come out at the bottom. Now there's an entrance and an exit for when I'm blowing air into this part. This probably saves me 10 minutes cleaning this part. Not 10 minutes, but a minute cleaning this part, so I don't have to get a stick and shove a stick down that hole and scrape it out. Now the air just goes in through the top and out through the bottom, and it'll carry all the rest of the SLS support material out with it. And so little details like that, which can be found on the Unconventional Manufacturing website, save so much time in cleaning, and so much like your people who are doing your process or post-processing will thank you so much for a little design detail like that only they know. A lot of times, like the best people to talk to about basically how to optimize your parts are the people who clean your parts. And so they're the ones who sit there all day long and try and poke every little detail out, and they're the ones who probably know your parts almost better than the designers do, because they've sat there and studied it 600, 700 times as they've cleaned it out, and they're like, every single time I do this one detail or two details.